Hello everyone, we are going to discuss about mole concept in this video. But before we come to the topic, we will have to discuss certain terms which are helpful in determining the number of moles of a substance in any numerical question. So let us first start with atomic mass. Atomic mass. In 19th century, scientists could determine the mass of one atom relative to another by experimental means. Now hydrogen was used as the reference atom because it was the lightest atom and the other atoms were assigned masses relative to it in comparison to it. But since 1961, carbon-12, an isotope of carbon, is used as the standard. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of one carbon-12 atom. At present, AMU has been replaced by another unit called unified mass and is represented by small u. We come to the next one. Next term is average atomic mass. Now, average atomic mass depends upon the abundance of all the isotopes of an element in nature. In periodic table, atomic masses for different elements are actually their average atomic masses. That means they have been calculated by keeping in mind or by considering the abundance of all the isotopes of any element. Next is molecular mass. It is the sum of atomic masses of all the elements present in a molecule. Like I have taken an example over here as methane. Methane is made up of one atom of carbon and 4 atoms of hydrogen. So we have to sum up the atomic masses of all the atoms which are present in methane. So 12.011 U, it is the atomic mass of carbon. 4, because we have got 4 atoms of hydrogen, into 1.008. 1.008 is the atomic mass of hydrogen. So when we find out the sum of all the atomic masses present in it, we get it as 16.043 U. So 16.043 U is the molecular mass of methane. Now next topic is formula mass. Now ionic solids do not exist as discrete molecules like any covalent molecule would be. They have positive and negative ions arranged in 3-dimensional structure. That means they have a different kind of arrangement, due to which we have a different term which is used to find out the total mass of the ions which is present in it. So for such ionic solids, formula mass is calculated instead of molecular mass, and it is calculated in the same way as we do a molecular mass. Let us take up an example of NaCl. NaCl, you know that it is a salt, sodium chloride, and it is made up of Na plus and Cl minus ion. So how to find out the formula mass of NaCl? It is done in the same way as we would calculate molecular mass. Atomic mass of Na plus atomic mass of chlorine. So it comes out to be 23 plus 35.5. It is equal to 58.5 U. Now we are coming to the main topic of discussion, that is mole concept and molar masses. First of all, to understand this topic, we have to understand what is actually a mole and what is the need of introducing this concept in chemistry. So like if I ask you to bring 1 kg of apple and each one of you will bring 1 kg of apple for me, can you say that the number of apples that has been brought by you will be same in all? No. Someone who has brought bigger apples will have less in number in comparison to those who have brought smaller apples. Though the mass of the apples is same, but the number of apples will not be same. Similarly, if I ask you to bring a dozen banana, all of you will bring 12 bananas for me. because a dozen means 12. Similarly, 1 mole is the amount of a substance. I repeat, 1 mole is the amount of a substance that contains as many particles as there are in 12 grams of carbon 12 atom. Now what is this number then? The number of particles present in 1 mole of a substance is known as Avogadro constant, and it is represented by 6.022 into 10 to the power 23. So if I ask you to bring 1 mole of iron, you will bring these many 6.022 into 10 to the power 23 atoms for me. If I ask you to bring 1 mole of copper, you will again bring these many particles of copper for me. So a mole is a more reliable concept that helps us in determining exactly the amount of a substance uniformly throughout the world. So I repeat once again, what is 1 mole? 1 mole is the amount of a substance that contains as many particles as there are in 12 grams of carbon 12 atoms. So you can see over here that 1 mole. Now if we talk in terms of molecules, so 1 mole of water molecules will contain 6.022 into 10 to the power 23 molecules. If we talk in terms of atoms, again it will be 1 mole of hydrogen atoms is equal to 6.022 into 10 to the power 23 atoms. So whether we are talking in terms of particles like molecules or atom, it gives us the exact number of particles that any 1 mole of any substance would have. Now how to calculate a mole? Formula to calculate number of moles. So the first one is number of moles of atom. Number of moles of atom can be calculated by the formula, from the formula given mass upon atomic mass. Now this mass, you have to keep in mind that the given mass must be in gram. Even if it is given in kg or in any other unit of mass, we have to convert it into gram and then substitute the value of mass in the given formula. So again I repeat, number of moles of atoms. Number of moles of atoms is given by the formula given mass in gram upon atomic mass. Now we come to the next formula. Suppose the mass, now this is number of moles of atom, like I gave an example of copper, iron. But what if the atom is present in the form of a compound? If the element is present in the form of a compound, then how we will calculate the number of moles? So number of moles of molecules. The number of moles of molecules can similarly be calculated by the formula given mass in gram. We have to take the mass of the substance in gram upon molecular mass. Now since the element was present in the form of compound, then we have to calculate it by using this formula, where in the denominator we will have the molecular mass. Like I can give you an example as, calculate the number of moles of calcium carbonate in 100 grams of it. In the given mass is 100 grams. Then we will first of all find out the molecular mass of calcium carbonate. Calcium carbonate is CaCO3. That means it consists of 1 atom of calcium, 1 atom of carbon and 3 atoms of oxygen. So first of all we will find out the sum of the atomic masses of all the elements which are present in calcium carbonate, and that will be the molecular mass, and we will substitute in the given formula. So number of moles of molecules will be given by given mass in gram upon molecular mass. Now the next is, if it is given in terms of number of particles, number of moles of particles is equal to number of particles upon Avogadro number. Suppose if they give you the question like, calculate the number of moles of hydrogen atom in 12.077 into 10 to the power 23 atoms. If it is done like this, then the given number of particles will be taken as the numerator, and upon dividing it by Avogadro number will give you the number of moles of particles. Then what is molar mass? The mass of 1 mole of a substance in gram is called its molar mass. Keep this in. The mass of 1 mole of a substance in gram is called its molar mass. Suppose the mass of 1 mole of a substance, like atomic mass of oxygen is 16. So molar mass of oxygen atom is 16 gram. And if we talk about oxygen molecule, you know that oxygen molecule is made up of O2. It consists of 2 atoms of oxygen. So it becomes 16 plus 16 is 32. So molar mass of oxygen molecule is 32 gram. I repeat once again, molar mass of oxygen atom is 16 gram and molar mass of oxygen molecule is 32 gram. Now what is the volume of 1 mole of an ideal gas? 1 mole of an ideal gas occupies 22.7 liter at STP. STP is standard temperature and pressure. I repeat, 1 mole of an ideal gas occupies 22.7 liters volume at STP. Now next topic of our discussion is how to calculate percentage composition. Percentage composition, it is the percentage by mass of each element in a compound, and it is calculated by using this formula: mass percent of an element is equal to mass of the element upon molar mass into 100. Empirical formula versus molecular formula. First of all, we will have to find out and understand what is the difference between empirical formula and molecular formula. So empirical formula, it is the simplest whole number ratio of various atoms present in a compound. Okay, simplest whole number ratio. And then what is molecular formula? It is the exact number of different types of elements, types of atoms present in a molecule of a compound. So if we take an example of ethane, the molecular formula of ethane is C2H6. It represents the exact number of atoms of every element. It tells us that ethane molecule is made up of 2 atoms of carbon and 6 atoms of hydrogen. So when it represents the exact number of atoms of any element, then such type of formula is known as, or such type of representation is known as molecular formula. But then what is the difference between empirical formula? Again, empirical formula of ethane is CH3. So CH3, it is representing the simplest whole number ratio. You can see that ethane is made up of C2H6, that is 2 atoms of carbon and 6 atoms of hydrogen. So when we find out the simplest ratio, it comes out to be CH3. So I hope you must have understood now what an empirical formula is. It is the simplest whole number ratio of various atoms present in a compound. So the simplest whole number ratio between carbon and hydrogen comes out to be 1:3. So the empirical formula of ethane is CH3. Now let us learn the some formula related to empirical formula, and then we will do a question based on it, which I have taken from the NCERT book itself. Another term is empirical formula mass. It is the sum of atomic masses of various atoms present in the empirical formula of a compound. So as you have calculated molecular mass, similarly you will calculate the empirical formula mass. So how we will do that? To calculate the empirical formula mass, since the empirical formula of ethane is CH3, so we have to find out the sum of all the atoms present in it. We have 1 atom of carbon and 3 atoms of hydrogen. When we will sum up the atomic masses of all these 4 atoms, we will get the empirical formula mass. Now N is the ratio of molar mass upon empirical formula mass. This formula is also important. N is equal to molar mass upon empirical formula mass. What is a molar mass? Molar mass is the mass of 1 mole of a substance in gram. and empirical formula mass I already told you just now. Now we come to the question which I have taken from the NCERT, question number 1.3. This question belongs to the exercise of the first chapter of your book. So let's see what the question is. The question is to determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen by mass. Dioxygen is the oxygen gas. So oxygen gas, since it is O2, it is also called as dioxygen. So what is the percentage composition given? It is given as 69.9% of you have iron and 30.1% of dioxygen or oxygen. So we have to make a table like this to find out the empirical formula of the compound. In first column we will write down the elements. So what are the elements? Elements are iron and oxygen, and then in the next column we will write down percentage. So percentage of iron was given as 69.9 in the question and 30.1 for oxygen. So in the third column we will mention the atomic masses of the elements. We know that the atomic mass of iron is 55.8 U and oxygen is 16 U. So we have mentioned the atomic mass in the third column. Now in the fourth column is the calculation for number of moles. We will calculate the number of moles from these two data. How can we do it? Percentage is given 69.9. What does it show? It shows that if we have got 100 gram of a compound, then in 100 gram of the compound 69.9 gram of it will be made up of iron. So percentage composition means this part. Suppose you have got 100 gram of iron oxide, then in 100 gram of iron oxide it will consist of 69.9 gram will be iron and 30.1 gram will be oxygen. So now we have got as I told you how to calculate the number of moles. Number of moles is equal to given mass upon atomic mass. So the same formula we are going to use. Now 69.9, as I told you, it was in percentage. So the given mass in gram comes out to be 69.9. We will divide it by the atomic mass, which is 55.8, and it comes out to be 1.25. So 69.9 upon 55.8 is equal to 1.25. Similarly, we will calculate for oxygen. So given mass in gram 30.1 upon atomic mass, which is 16, it is coming out to be 1.68. So in the fourth column we are calculating the number of moles. So we have already calculated the number of moles of each element. Now in the next column we will have to find out the simplest ratio. So to find out the simplest ratio, suppose you have got two or even more elements might be present in a compound. So whichever is the smallest number, we will divide all of them by the smallest number. So here we are having 1.25. This number is the smallest, so we will divide all of them by the smallest number. So you can see that to find out the simplest ratio, we are dividing the answer, that number of moles, all the number of moles that you have calculated, we have to divide it by the smallest number. So we are getting it as 1.25 upon 1.25 is equal to 1. Similarly, 1.88 upon 1.25, it is equal to 1.5. So the answer we have got 1 and 1.5, but this is not a whole number. 1.5 is not a whole number. So we have to convert it into simplest whole number. How can we convert it into simplest whole number? If I multiply both the numbers by 2. If I multiply both the numbers by 2, I will convert it into simplest whole number. So I have multiplied 1 by 2 and answer is 2. Again 1.5 I have multiplied by 2 and I get the answer as 3. So 2 and 3 are the whole numbers. So now we have got the answer. We are having 2 atoms of iron and 3 atoms of oxygen in the empirical formula of the oxide of iron. So therefore the empirical formula is given by Fe2O3. This is the empirical formula. Now empirical formula mass, how to calculate? As I told you, you have to find the sum of all the atoms present in the empirical formula. It comes out to be 2 into 55.8 plus 3 into 16. So the empirical formula mass of iron oxide is coming out to be 159 U. 159 U. That's all. In my next video I will be discussing about stoichiometry and stoichiometric calculations.